Okay. So for proofs, we have to determine all NPVs on both sides of the equation and verify the possibility of the identity in two ways, an example or graphing. What should happen when you substitute the same value in both sides of an equation for values of x in the equation as an identity? What should happen if, when you have a trig identity equals a trig identity, and you substitute the same value of x into both sides? What should happen? If you have something equals something, right, and you substitute the same x value in, and you should get the same answer on both sides, correct? That's one way to verify. So now, does that prove that it works for every, that statement is true on both sides always, if for one example it works? No, that just shows for that one example it works. So what you need to do is actually, we're going to be doing proofs soon, where you have to prove the left side equals the right side without filling in the x's. Get the left side to look the same as the right side. So when you do something to this side and you do something to this side, they'll both say equal sine x, let's say. So at the end you have sine x equals sine x. That shows that it works, that they're true for every single case. But if you're just verifying by filling in a value, that just proves that it works for that value. If you put in another value, it still shows that it works for that value. Okay, so you're just verifying a value. So here's our identities, right? And I went over this yesterday. If it's cosecant, then we'd have to say where sine x can't equal 0. Bless you. If it's secant x, you'd have to say where cos x can't equal 0. If it's tan x on the bottom, you have to say where tan x can't equal 0. But what's tan? What is tan? Sine over cos. So you'd have to prove where sine x can't equal 0 and cos x can't equal 0. So if ever you have tan or cotan in the denominator, you have to tell me all the places where sine x and cos x can't equal 0. If you just had tan, you tell me where cos x can't equal 0. And if you just had cotan, you tell me where sine x can't equal 0. We'll do examples of that on the next page. So it's just whatever's in the denominator, right? So often they go more so with like having sines and cosines in the bottom than tans in the bottom. Because if you have a tan in the denominator, you have to state both. But if I had just cotan, then I'd have to state sine, which is confusing, right? So often they don't use the cotan version because you could fight two different ways, which would be correct. So we're going to verify this first, and then we're going to do some NPVs. So it says verify cos squared theta plus sine squared theta equals 1. This is a formula on your formula sheet. This is just the Pythagorean theorem identity. A squared plus b squared equals c squared, which makes sense because it's x squared plus y squared equals r squared, right? That's the formula. So our x and our y are sine squared and cos squared off for a unit circle, and then equals 1, because our unit circle's radius is 1, right? Remember the formula is x squared plus y squared equals 1 when you do the unit circle? That's this identity. Now, this identity can be arranged in different ways. So what you could say is cos squared theta equals 1 minus sine squared theta. Or you could say sine squared theta equals 1 minus cos squared theta. So any of the formulas on your formula sheet, you can rearrange as well. So this and this are just rearranged forms of that. They're just that one formula rearranged. And you can rearrange any of those formulas. So verify that this works. If they say this on the diploma, they literally just want you to plug this in and see if left side equals right side. So we're going to go cos squared pi over 6 plus sine squared pi over 6 equals 1. Remember, this squared in the inside is just like saying cos pi over 6 all squared, right? They just put the squared in the middle for some unknown reason. I think it's so that, I think they put the squared in here so that they don't have to go bracket squared. Because if not, if you put a squared here, then the pi over 6 would just be squared, right? So you have to do the whole thing squared. So instead, they put the squared in the middle. So what's cos of pi over 6? Root 3 over 2? And then we have to square it, because they want cos of pi over 6 squared. And then sine of pi over 6 is a half squared. So root 3 over 2 squared, when you square a square root, it just goes away, right? And you have to remember to square the bottom. So it's 2 squared, which is 4. So you're going to get 3 over 4 plus 1 over 4 equals 1. And then this is going to be 4 over 4, because we have common denominator equals 1. So 1 equals 1. So you verified it worked. These other two formulas down here, you guys, so the 1 plus tan squared equals secant squared, and the 1 plus cotan squared equals cosecant squared, just happens when you take this formula up here and you divide by sine. You'll get one of them. So if I divide this one by sine, it becomes a 1, sine squared. Divide this one by sine squared, you get cotan squared. Divide this one by sine squared, you get cosecant squared. Oh, it's this formula. When I take this and I divide it by cos squared, sine divided by cos is tan squared. Cos squared divided by cos squared is 1. And 1 divided by cos squared is secant squared. So these formulas are literally just this formula divided by sine or cos. Yeah. Yeah.
On a test, if we were to see this question and it didn't equal 1, would you
It will.
say, oh, okay,
If they say verify,
okay.
they're saying verify
Just
it works.
Show the work.
Yep. Some people will say, well, I can just plug it in my calculator and get decimals. The way they will do it is like they did it in these steps where they make a mistake, let's say. And if you just have decimals, you'll be like, oh, they didn't punch in their calculator. Obviously, that's where they made a mistake. But that's not an option, so you can't pick that. Okay? So these ones, if you divide by sine squared, you divide by cos squared, you get the other two formulas. What's great about it? They're given to you, so you don't have to find them. Okay? But that's just how they found them. So that's how they got these ones, right? And then you can rearrange these too. If you had 1, you could replace it with cosecant squared minus cotan squared. If you had cotan squared, you could replace cosecant squared minus 1. Like you can rearrange any formula on that formula sheet, okay? Which would be helpful when we go to do proofs. Not so much right now. So let's look at this one. If is cotan squared sine squared equals cos x an identity? Well, there's 3 ways we can look at this. Well, there's 2 ways for now. We're not going to do proofs because proofs come in the next lesson. Well, 2 lessons. Okay? We're not going to do a proof where you show that it actually works by replacing, but we're going to do the 2 other methods. So one of them is we're going to replace into both sides and see. The other one is we're going to plug it into our calculator. But the one thing you have to watch with calculator is calculator isn't always helpful because sometimes you'll end up with, like for this side example, you're going to end up with asymptotes. Because cotan actually is going to get you non-permissible values. Whereas will this side get me non-permissible values? It's just cos. There's no denominator. So what happens is you'll actually get the same graph. They'll look the same, but this one's going to have asymptotes and that one just won't. So it is not the best way to check by your calculator, but it is another method you can use. Now, what happens if on the diploma or on a test they had which of the following is true? And they'll give you like an identity, like, for example, cotan squared x equals cotan x times sine x. And then they'll say is equivalent to A, B, C, and D. It's multiple choice, right? And A is like sine x, and B is cos x, and D is secant x, and C was cosecant x, let's say, right? What you could do on the diploma is you could actually plug into here 45 and then plug into all your answers 45 and see which one gets you the same answer, right? Could you not? If they give you both parts of it, if they give you this equals this, but this equals is the part A, B, C, or D of the diploma, you could plug in 45s and see which one matches the original, right? You could verify that way. So they want us to determine all NPVs first. So we have cotan, so we have cos theta over sine theta times sine theta equals cos theta. I always convert all of them into sines and coses and then do my NPVs from there. So what's our only denominator? Sine, right? So we have to state where sine theta can't equal 0 because we can't have that denominator equaling 0. Where does sine or y equal 0? On the x-axis, right? Sine y equals 0 on the x-axis. So 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, negative 2 pi, negative 3 pi, negative 4. Am I going to keep doing that for life? Yes. But am I going to actually do that on the test where I'm going to write that? Please don't. Okay? They're going to ask for general solution. So you're going to say, remember how we did this? Theta equals, if we wanted to, we could go 0 degrees plus 180 degrees n, NEI. But what did I tell you about the 0? They don't write it. So we get 180 degrees n, sorry, it can't equal 180 degrees n, NEI. Or can't equal pi n, NEI. This one is such an awesome, super easy identity that you can see that this is actually going to work really quickly by a proof. Because if you look, how can we make this side equal to each other? Well, we switched cotan into cos over sine. Only they were this easy, always. Times sine equals cos. Oops. We stated our NPVs, so now we can cancel. And we have cos theta equals cos theta. We've proved it. So we actually proved for every example it works, because we have left side equaling right side once we've reduced it. Okay? They also ask you to verify with values. So it says evaluate both sides for 45 and pi over 3. So we're going to take this one and we're going to evaluate it for 45 and for pi over 3. So cotan 45 degrees, sine of 45 degrees equals cos of 45 degrees. Cotan of 45. At the 45s, we either have 1 or negative 1s for cotans and tans, right? Because it's always root 2 divided by root 2. Root 2 over 2 divided by root 2 over 2, sorry. So it's in the 45, which means it's going to be positive because everything's positive there. So we're going to have a positive 1 or a negative 1? Positive 1, right? Because cotan's positive there. So we're going to get 1 times tan sine of 45, which is root 2 over 2, equals cos of 45, which is root 2 over 2. So you have root 2 over 2 equals root 2 over 2. All right. I often do not choose 45. I usually choose 30 or 60 because the odd time with tan and cotan, because they turn into 1s, it sometimes does weird things. Like I never pick the angles that are on the arms either because they're 0s and 1s. So I usually pick 30 or 60 to plug in, like if I have a choice. In this case, they gave us 60 or pi over 3. So we're going to do cotan of pi over 3 sine of pi over 3 equals cos of pi over 3. Cotan of pi over 3. Cotan is cos divided by sine, right? So it's going to be a half divided by root 3 over 2. which is a half, times 2 over root 3, which is 1 over root 3. What does that rationalize to? Root 3 over 3. So I'm going to get root 3 over 3 here. And I'm going to times it by sine of pi over 3, which is root 3 over 2. And then cos of pi over 3 is a half. And now people are freaking out. There's no way that these are going to equal. They actually are. What's root 3 times root 3? 3. What's 3 times 2? 6. And then they want us to prove graphically. So y1, y2. So I'm going to go into my y1. And I'm going to go cotan. What's cotan? How do I type in a cotan? 1 divided by tan. Oh, in my y equals 1 bracket 1 divided by tan x. And what am I multiplying it by? Bracket sine x. Bracket, bracket. And then y2? Now, I'm going to show you something. I'm going to pick my mode, and I'm going to pick it in degrees because I just feel like it. I was to pick my mode first. I hit enter. And then I'm going to go zoom trig. And it's going to zoom trig my calculator into a mode where I can probably see it at the very least. Now, this is the problem. People will say, well, they drew on top of each other. I can only see one graph. Yes, but what happens if actually they didn't draw on top of each other? Your other graph is like flying up here and you don't know it because you're just assuming they drew on top of each other because you can't see a different one. The best thing to do is go to your y2 and arrow over and make it thicker, because then you'll actually see if it draws on top of the other one, not just hope that it did. So hit enter, it's thicker, and now I'm going to watch it. That's my first one. So do you see here, it's actually making a break in the graph right there? This is not going to. That one's going to cover the break. Why is there a break here and a break here? It's because there's those NPVs are there, right? What are the ticks at? Well, I don't know. Somebody go to the window. My ticks are at 90. My X scale is 90. So this is a 90. This is a 180. This is a 90. This is a, what did we say our NPVs were at?
It's tight. You slept that's tight, actually. It's fun.
Yeah, I know. Super great. Okay. So like I said, we verified using these, but it kind of is a little dicey because we do know that there's actually NPVs where the other one isn't, right? These ones just happen to not have NPVs. Why too? Because if I showed you up here, look, that sign crosses off, right? And that's why they end up matching each other, because the NPV actually cancels.
Good question.
Yeah.
Why did some math classes learn?
Okay. Cosecant equals 0 where? Where does x equal 0? 90 degrees. X can't equal 90 degrees plus 180 degrees n NEI. And it can't equal pi over 2 plus pi n NEI. They're the same thing.
No, but it's an N.
It's got an N, so it's like all of, yeah. I get what you're saying. Yeah, no. But that would be one of the answers. Incorrect. Okay, when you see a tan in the denominator or a cotan in the denominator, you should have a little happy face on because it happens. What was that? Happens everywhere. 90 and the 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 90 and 90 and 90 and 90 and 90. Yes. So x can't equal 90 degrees and NEI.
That is so easy. For the first time.
Okay. Sine x equals -1. Where does y equal -1?
Oh, when it's
Yep. Where does that happen?
in the third and fourth quadrant.
270. So 270, which is 3 pi over 2, and then every 360 or 2 pi, right? So x can't equal 270 degrees plus 360 degrees and NEI. Or in radians, that's x can't equal 3 pi over 2 plus 2 pi n NEI. And where does sine x equal 0? Where does y, what? Every 180. Yeah.
Thank you.
Because it starts at 0, right? But we don't write the 0. Okay, where does cos x equal 1? Where does x equal 1? At 0. Or 180, 360. No, cos x equals 1 only at 0. 360. It's -1 at 180. So you could go 0, if you wanted to, you could go 0 degrees plus 360 n NEI, but we don't write the 0.
Oh wait,
So that would go away.
what is that for? The one in the red in the middle, like the x equals 180f. That's oh shoot.
So instead of writing 0 plus 360, we're going to say x can't equal 360 degrees n NEI. And cos x is 0 at every 90, 270, 90, 270. So x can't equal 90 degrees n plus 90 degrees. I don't know, I just put an n there, sorry. Plus 180 n NEI. Or x can't equal pi over 2 plus pi n. So for B, they want us to do restrictions on tan x and cosecant x. The very first thing you need to do is turn them into coses and sines. Okay? So tan x is sine x over cos x. And cosecant x is 1 over sine x. So basically, we need to say where cos x can't equal 0 and where sine x can't equal 0. This is our happy place. No, it's a plus sign. Plus, you always state NPVs before you cancel, even if you could cancel. So cos x and sine x can't equal 0. That's our happy place, because that's every... Yeah?
For the like in the question when it says 4, 0, 2 pi, why is it a curly bracket, not a square?
Not equal to 2 pi. So if 2 pi actually was an answer, you couldn't give it. Because it's greater than or equal to 0 and less than 2 pi.
Oh.
Yeah. So it would be 0 would be counted. Oops. 0 radians. And then we would count pi over 2, which is 90. We would count pi. We would count 3 pi over 2. But we wouldn't give the answer 2 pi. Because they gave us a restricted domain where they wanted the NPVs, right? Then here it says state the general solution. Well, the general solution is just x can't equal pi over 2n, NEI, every 90.
Jeez.
It's not as bad as it looks. We'll look at B first. What do we always do? Turn them to coses and sines, right? What does secant squared x mean? It just means secant x times secant x, correct? That's all it is. So you would get 1 over cos x times 1 over cos x times cos x over 1 over sine x. This is actually extremely easy. What's in my denominators? Sine and cos. So, what's my NPVs?
Sine and cos. Would you,
Where did I get what?
what led you to say pi over 2?
Because cos is in the denominator and sine.
Yeah.
I have to say where cos and sine can't equal 0. And cos and sine can't equal 0 at every quadrant.
Oh.
90, 90.
Oh, so that'd be every 90.
Yeah.
Oh, right. Okay. That's your right.